Alrighty, what do we have for Arrhenius acid? What's the Arrhenius acid? What needs to happen? There's some requirements.
Liberates hydrogen ions
Okay, so the
when placed in water.
concentration of hydrogen ion has to go up, and there's one other thing. It's specifically defined as happening in water. And so what about the base?
Isn't it hydroxide?
So hydroxide concentration goes up. And again, Arrhenius is talking about water. All right. How about that Bronson-Lowry acid? So since hydrogen ion is really just a proton, their definition says any substance that donates a proton is an acid, and this is also in water. And so what's their base definition?
Accepts.
Okay. And Lewis? So a substance that will accept the lone pair of electrons to form a bond, and there is no mention of water, and should not be any mention of water. And so then it's a substance that donates. All right, so what's wrong with Arrhenius's definition? Don't need water. Anything else?
Hydrogen won't hang out by itself in water.
Okay. Something else? Or what about this nitrogen one? Nitrogen has that lone pair of electrons. It'll make 3 bonds and have a lone pair. So because it has that lone pair, it is a Lewis base. It acts as a Lewis base. And why is this important to us? Yeah, this is the you don't have hydroxides floating around in solution in a biological system. person or a dog or a plant, they don't have a whole bunch of OH just free floating. But what they do have is a lot of nitrogen, and the nitrogen itself can be used as the base, and it is used as the base. So lots of different ways to get acids in the body, and nitrogen is almost always the thing that's the base that's inside of a body. So acetic acid. So which one of these is the acidic H?
The one to the right, my right, attached to the oxygen.
Yeah, can you give me a couple reasons why?
The C double bonded with the O, and then, yeah, that is an organic. Isn't it, or
Yep.
chemical reaction?
So that section of the molecule is considered the organic acid. Anything else? That one on the far right isn't like the other three. So if it was one of the other three, which one would it be? They're all exactly the same, right? So it couldn't be one of those. So that's your other way that you can figure that out. But the first answer is definitely the best answer. Describe how to make 750 milliliters of 2 molar hydrochloric acid solution with concentrated hydrochloric acid. So then the first thing you need to know is what concentrated hydrochloric acid's concentration is. And what is that? 12. So this stuff here is 12 molar. And what I need is 750 milliliters of 2 molar. So it's a M1V1, M2V2 problem, right? What I need to know is how much of the concentrated stuff do I need to put into this 750 milliliter beaker? So 12 molar times volume 1 equals 2 molar times 750 milliliters. So volume 1 equals, does somebody have a number? Times.
25, I think.
Okay. All right, so add 125 milliliters of 12 molar HCl to 750 milliliter vol flask. And then fill near the line, and then fill 2 line with dropper. And if you invert once, it'll be mixed. Since it's since both of these are solutions, you can kind of skip the whole fill it part way and shake it up. You're not going to need to shake it up because these are both liquids, so they'll just need to flip it over one time and you're good to go. You mix that and that, what will that give you? Okay, so I've got the exact same concentration of 2 substances and the exact same volume of those 2 substances. So if I take nitric acid and I mix it with potassium hydroxide, so we'll say aqueous and aqueous, and what are my products going to be? What do you get when you take an acid and mix it with a base? Ocean. Think ocean. I put these 2 things together and I get salt water. That's what I get. So where's the water come from?
The H
There's my water molecule. And then whatever's left over, that's my salt. So this will be a liquid. And so then my salt in this case will be potassium nitrate. Why am I going to put the state down as aqueous? Yeah, this whole thing happened in water, right? It was aqueous nitric acid, it was aqueous potassium hydroxide. I made water, so this potassium nitrate is definitely still sitting in water, and since it's potassium and nitrate, the thing is definitely still aqueous.
And it's gonna be 2 molar.
And over here, I'm gonna have, this is gonna be 2 molar. How come?
Because the other two are both.
So since this is 2 moles per liter here, right? When the nitric acid, which is what type of acid? It's the last thing we talked about on Thursday. Strong, which means when it goes into water, the H just comes off. It fully separates, the H and the NO3 completely separate. So if you had 2, let's just say I had 2 of these things here, 2 of the nitric acids, and then they both split. How many H pluses would I have? 2. And nitrates? 2. So if this is 2 molar on this side, do you see this has to be 2 molar on this side? Because what I got were, I've got 2 molar of this, so there's 2 molar of the nitrates, and this over here, the hydroxide is 2 molar, so that means I've got 2 molar potassium, so that means there's 2 molar potassium on this side. This would be different if the volumes were different, or the concentrations were different, or what other way could it be different? What if instead of using, say again?
Not strong acid.
That would change things a little bit, but we haven't talked about that yet, but it would. It would be different if instead of this being potassium hydroxide, what if it was calcium hydroxide?
So then your charges would be different?
Then your equation's not balanced, right?
And my equation's not balanced, and a volume, or the number of particles is different, right? So in a 2 molar solution of calcium hydroxide, I have 2 molar calcium ions, but what's my hydroxide ion concentration? Double that, right? Because every time I've got a mole of calcium hydroxide, I have 2 moles of hydroxides. So that's how we need to be thinking about these things. So if I had the same problem, how much of the nitric acid would I need to neutralize out the hydroxides? You see, I'd need either 20 milliliters or 4 molar. Because when this, if this was the problem here, when this went into water, it would split and I would get 2 hydroxides. So that's 2 molar hydroxide, or 4 molar hydroxide, so I'd need twice as many H pluses. So I can either double my volume here to 20, or I can change this concentration to 4 molar, or I can switch the, oops, I'm circling the wrong stuff. Could change this, or then I could actually change this acid to say sulfuric acid, because then it comes with 2 H's as well. So the 2 H's would neutralize out the 2 OH's, and then I get my water molecule. So lots of different ways I could actually do this. Would a solution be acidic, basic, or neutral if you mix that and that? Okay, so I've got sodium hydroxide, and I've got, how much of it? 10 milliliters and 2 molar. And I'm gonna mix that with some more nitric acid. And I've got 5 milliliters, but this stuff is 4 molar. So first off, what are my products?
Water and sodium nitrate.
Water and sodium nitrate. Aqueous, because it's sitting in water. Liquid, because it's water. And so tell me about the sodium nitrates concentration. How about forget about tell me what the concentration is, just tell me, is there any leftover, so let's do it like this. This is my base, right? Oh geez, that's really bright. I thought that was a see-through. It is not see-through. So when you guys were messing around with the litmus paper last time, bases were what color? With litmus paper, you only had 2 options. Red or blue. So the bases were what color? The bases were blue, so there's my base. And then my acids were red. Okay. So do I have any leftover blue or leftover red after these two things have reacted with each other? I've got twice as much blue and half as much red, but the red is twice as concentrated than the blue. So what
They all
happens?
cancel each other out.
They just cancel each other out, right? So how could you know that mathematically? This is 2 moles per liter, and this is 0.01 liters, and this is 4 moles per liter, and this is 0.005 liters. So out of this I get 0.02 mole of H, and I get 0.02 mole of OH minus. So what are these two things going to do? Completely cancel each other out, and I'm just left with water. So what's the answer to this question? It's neutral. Yeah, this is a neutral solution.
And if everything's constant, would that just about always happen with this, because it's a strong acid and a strong?
This will always happen with strong acids and strong bases. If you have equal moles of the acid and equal moles of the base, then they'll completely cancel each other out, and you get salt water. Absolutely. So if somebody gave you some acid and told you to drink it, but you had some base, you could just neutralize it out, right? And what would you be left with? Just salt water. So you may or may not want to drink it as salt water. But yeah, we'll actually talk about that, something like that in a little bit. Okay. Do we have questions about that one or the last couple?